Okay. Yeah, so my screen is visible.
Yes, sir.
Okay, so first, so these are the 4 columns. So we have already released on the Monday. So I hope you have already solved. If you're not solved, you can see the solution today. So these are the 4 type of problems. So in the OPP exam, level of the problems will be approx similar or to these mock problems, but problem can be different. I mean, it can be from different topics also. So first problem, basically swapping min max. Okay, so what is the problem? So we will discuss the problem first, and then we will discuss the solution. So problem is that you are given 2 lists A and B of n positive integer. You can apply the following swap operation to them any numbers of times. Okay, so there is one swap operation is given. So you can only apply this swap operation to solve this problem. So what is the swap operation? Select an index. Okay, so I where I is greater than equal to 1 and less than equal to n, and swap AI with BI. Okay, so we have 2 lists actually, and we can swap the element at index AI with BI. Okay, so AI become BI and vice versa. So we can swap the element with the corresponding index of the list. So write a function min max a comma b which takes 2 lists A and B of size n as input and returns an integer. What is this integer? So which integer is represented here, which is the minimum possible value of max a1 comma a2. That means the list of elements from so elements from the list 1 multiply max of list elements from the list 2. So maximum element from the list 1 multiply maximum element from the list 2. This multiplication should be minimum. Okay, so you can get after apply the swap operation any number of times, possibly 0. Okay, so basically our main purpose here is to get the minimum most possible multiplication of maximum of list 1 and maximum of list 2. So this is the question, and here one swap operation is given, so we can apply this swap operation any number of times on the list, and after that we have to return this minimum possible value for this multiplication. If you are not getting these things from the problem statement, what we are supposed to do, so you can see the example also. Okay, so what example is saying that consider the list A equal to this, these are the elements 1 comma 2 comma 6, these elements, and B have the different elements. In the case if you can apply the swap operation at indices 1, that means if we apply the swap operation on 2 and 3, okay, so that means the element will be replaced on the list, and we are also applying the swap operation on fifth index. Okay, so that means the second last element 1 will be replaced by so fifth index is 0 1 2 3 4. Okay, last element. Okay, so last element will be replaced by 2 and 5, that will be replaced on other say corresponding place. So after that, if we find out that what is the maximum element of list 1 and what is the maximum element of list 2, we will multiply this and we will get this value 18. So this is the possible minimum value. Okay, you cannot find the more minimum value compared to this by any other combination. Okay, so that means what is the problem and what we have to find out, that these things are clear to everyone. We can also take an example to solve. Okay, so these are 2 lists basically, 1 2 6 5 1 4. Okay, and second list is 3 4, 3, 2.
Sir, I have one doubt.
Yeah. Okay. 1 second.
Sir,
Yeah.
I have one doubt.
Yes. Yes, ma'am.
Sir,
Mm-hmm.
okay. So, sir, it is said that we have to return the minimum value, but minimum value from which will be the multiplication of maximum of these two lists. So that is always be unique. I mean, there will be only one maximum of uh, this list, and that I mean, why minimum? Minimum is there will be multiple values, and I have to return minimum among them. So
So actually, we are selecting maximum from first list. Okay.
yeah,
And we are selecting maximum from second list. But we are selecting these maximum after performing swapping operations.
okay,
Okay, that means we can perform one given swapping operation in which we can swap the elements to the corresponding index.
yeah,
Like this thing. So we can swap second index, we can swap. Okay, so after swapping, the multiply of to these maximum should be minimum of the all possibility. So for example,
okay, got it.
if you are selecting maximum from directly here, okay, so what is the maximum from first list is 6,
6,
and what is the maximum from here?
5,
This is 5. So 6 into 5, you are getting 30.
30.
Okay, but how you can perform this given swapping operation on these two lists? So this multiplication will so this
I
multiplication
understood,
should
sir.
be minimum. Yeah.
Yeah, 2 and 4 will be interchanged, and at last 2 and 5 will be interchanged.
Yes, so
Then we'll
these
get the
things we
minimum.
have to find out how we can how many number of swap operation we should perform to
Okay.
get this.
Okay.
Okay, so this is not a random thing. We cannot perform this swapping randomly. So we have to perform some sequential tasks to check these things. So we will perform this task in our solution.
Okay.
Yes. Okay. So how we can solve this? So basically, we can swap our elements according to some strategy like this. So for example, we compare the element from the starting index from the first index, okay, from the here, and we will check that if the value of the first list, for example, we are just comparing the element of this 1 and this 3. Okay, if the the element of the first list is minimum from the element of the second list, so we will perform the swap operation. That means actually our main purpose is here. We want to uh, collect all the big numbers in one list, and we want to move all smaller number into the second list. In that case, for example, so in the second list, for example, if I shift this 5 the first list, so corresponding we will get 2 here. Now same things, so what is the bigger element here is 4, so we can, if we can swap this, so this 4 will come in the first list, and the corresponding to 2 will come here. Now after that, in the second list, the what is the bigger element is 3. So there is no possibility after that. For example, if I am also shifting this 3 by 1, so we will get 1 here and 3 here. Still we are getting this 3 in the second list as a maximum element. Okay, so if we want to perform these things, if we are performing swapping from this 3 by 6, so we are getting the bigger value in the second list. In that case, that means our purpose will not solve. So we will shift all bigger element in one list and all smaller element into the second list using this swap operation. Okay, we cannot apply the other things. We cannot just find out the smaller numbers from the first list and directly shift it to the second list. We can perform only this swap operation, and this swap operation can be performed to the corresponding index only. So we will check these things. We will compare the element one by one. So here this 1 and this is 2. Okay, so we will just check that if the element of the list 1 is smaller, or we can also check for the greater. So for example, if I'm checking for the smaller, so we can check that if the element of the list 1 is smaller than compared to list 2 elements, so then we will perform the swap operation. So these things we will apply on the each combinations of the index. Okay, in that case, so what we will do, so for the first example, okay, so this one is smaller than this 3, so we will shift this 3 on the app of list. So for example, what will be the list after swapping? Okay, so this 3 will come on the first list, and this one will come here. Okay, so after this we will check this in the second index element. So this is 2 and 4, so 2 is smaller than this 4. Okay, we will perform the swap operation here also. So this will come here, this will come here. Okay, same thing, 6 is not smaller than 3, so we will not perform the swap operation. Same things, 5 is not smaller than 2, we will not perform. Now here 1 is smaller than 2, so we will keep remain the same, 6, 3, 5, 2, and after that 1 and 2. Here we are getting this smaller value in the first list, so we perform this swap operation. So it's 2, 1. Okay, now in the last, so 2 is smaller than this 5, so this 5 will come here, and 2. Okay, now you can see all the greater value is shifted in the list 1, and all the smaller value corresponding to the list 1 is coming into the second list. Okay, so we can select the maximum from list 1 and maximum from list 2. So we will get this maximum from here 6 and maximum from here 3, and this the multiplication we will get 18. So this is the answer, and there is no other combination where you can get this the smaller value compared to this 8. Okay, so
Yes,
this
sir.
is the, yes, someone, yes, Sahoni, yeah.
Sir, even if we don't swap the values, the maximum value will be same, na?
If we are not swapping the value, so the maximum value from list 1 is 6, and maximum value from the list 2 is 5. Okay, so 6 into 5 is equal to 30.
Okay.
Okay, so here we are getting 30 multiplication, and here we are getting 18. So this is the smaller, 18 is the smaller than 30.
Okay, yeah. Sorry.
Okay, so this is the way.
Hello, sir.
Yes, is there?
What if we, sir, exchange 3 with from the second list to 2 in first list?
Sorry, second, which element you want to swap?
I want to swap number 3 from second list to number 2 in first list.
No. This is not a given condition. In in the problem statement, it is given you can swap only the same index element from the list.
Corresponding position
Yeah.
only, sir.
Yes. Corresponding index element you can only swap.
Okay, sir.
Okay, this constraint is given in the problem. Okay, so this is the way to solve this problem. So after that, we can just choose the solution. So in the same concept, if anyone have another way to solve this problem, you can also share your solution if you have already solved.
Sir, how
Okay,
to use swap function? It is not given. I mean,
No, swap operation is given here. So select an index I, I is greater than equal to 1 to n, and swap AI with BI. Okay, so AI become BI and vice versa. So we are swapping the AI to BI.
So we have to write this swap function. It means.
No, this is a constraint actually, and this is the constraint for the swapping. So you have, when you are swapping, you have to remember these things. You can swap only the same index element in the both lists. So we are performing this swapping. You can make the function for that. Otherwise, you can perform this swapping in the simple way.
Okay.
Okay, if you see this solution here, so if I'm now the only 5 lines. Okay, so this is the solution for this problem is, so here we are just using one for loop for I in range len of a, because the length of the both list is the same. If ai is lesser than bi, okay, so here we are using this condition. So here you can see we are using the same index I for the both list. Okay, so if condition is true, then we are performing the swapping operation. So after complete this loop, we will directly find out the maximum element from list A and maximum element from list B. Then we will return this multiplication. Okay, so this is very simple problem, but sometimes according to the problem statement, so you can just if you're not getting the exact things from the problem statement, you can see the example or explanation, so you can get the information fast from the example. Okay, so this is the first problem, and if you have any other solution, anyone, you can also share any other approach. So in the OPP exam, there will be the 4 question and the question weightage will be different. Okay, so marks wise question marks will be different for all the 4 person. So first question will be easy level. Okay, it will contain the 20 marks, and second question and fourth question will have the same weightage 25 marks, and the level is medium, and third question is also a medium level, not a difficult level. So all questions are medium and easy. Okay, and this time is also increased, half an hour we have already increased in the duration, so time is also enough, you can easily solve.
So what are the passing marks?
Passing, there is no passing mark in the OPP exam. Okay, this marks is contributing in your final scores.
Okay, sir.
Okay, so for final score, you can, this marks will be contribute. I think sir 20% weight is there. I'm not sure. So this marks will be included in your final score. So there is no passing marks for this OPP all. Okay, now we will move to the second problem. Yeah. So here peak in Unimodal. Okay, so what is the problem? So consider a list A with n entries, with each entry holding a distinct number. Okay, the sequence of value a0, a1 to an minus 1 is unimodal. So here one unimodal term is given. What is unimodal? For some index p between 0 to n minus 1, the value in the array entries increase up to position p in A and then decreases the remainder of the way until position n minus 1. Assume length of A is at least 3. So there is one, this is the one condition given. So elements will always be more than or equal to 3 in our input list. Write a function peak unimodal that takes a list A as input and return the index of the peak in log n times. So that basically what we are asking here. So we are asking the maximum value in our list. Okay, so there is one order, there is an order given in the list. Here the list is starting from the small element and it is increasing one by one. So this is increasing at some points, after that it is decreasing. Okay, so if we draw the graph for that, so this is like this. So our elements are increasing and at some point after that our elements are decreasing. So this is a peak in our elements, that we can also say that this is a maximum element. Okay, so here one order is specified and the we are asking the what is the index of the maximum element in our list. So this is looking very easy problem. if you are trying to solve, you can simply write this. Okay. So just create a function name peak unimodal a return max a. Okay, because we are asking the maximum element from the list element. Okay, we are asking the index of. Okay, I think we are asking the index. Okay, so we can simply use max of a, then simply a dot index. So this is the one line code using Python we can perform, but this will return the correct answer, but in our code this will not pass the test case. So only one test case is passed because the input length is small. Okay, if you are seeing that, answer is correct, but other test case are very big. So in that case we are testing the complexity. This time we have also include this time things. So if your test case is not passing, then here the time, what is the execution time your code is taking and what are the approximation time should be, here those information we are giving to you. Okay, so and the problem statement, it is also given your solution should be also a order of log n time. Your complexity of your code should be order of log n. Okay, so when we are talking about this log n things, and we have an input which have some pattern, we can say that which have some sorting pattern. Okay, here we have some sorting pattern. So we are just we are applying the searching algorithm. Okay, so we can think about the binary search algorithm. So we can apply some binary search concept, because we know that we have some sorted pattern in our list, and we know that what is the sorted pattern. So sorted pattern is our elements are increasing from the first element, and at some point our elements are decreasing. So using this pattern we can just modify our binary search algorithm and we can apply on that. So one main things you should remember in the OPP exam, if any person have asking this type of complexity based person, so just remember that don't apply the slicing things. Okay, don't apply the slicing, don't use the slicing of the list in your binary search or any other sorting algorithms, like sorting merge sort, like this thing. Okay, don't use the slicing, list slicing, because the list slicing operation complexity is order n. So if you're writing the binary search code, so if you are using the slicing, then your code complexity will be order of n, not the log n. So write your binary search without this list slice. Okay. So now how we can solve this complexity based question here. So I'm taking one small input. Okay, so here one pattern is given. Okay, so if you see any, so for example, this is a peak element, this one is a peak element, okay, so this 52 is a maximum element, if you see that. So if you see the elements before this 52, okay, this is 2, 3, 4, 21, 43. Okay, this is the one, sorry, 21 and 43. Okay, and the another remaining elements are this. So 51, 18, 11, 11, 9, 6, 5, 1. Okay, and this is the 552. This is the peak element. Okay, if you see this smaller element, so if any time, for example, if you are applying the binary search, so you can identify that where is your peak element will occur. So if you see that, so for example, if you are applying this binary search concept, and you are just finding the mid element, okay, so at the time of mid element, for example, if your mid is coming here at this position, okay, so you can see that actually where is your the peak element here. So you just check that if the if you are getting this mid element 21, you can just simply check that the element before that this element is smaller, and if the element after this element is bigger, okay, that means if this pattern is coming uh, during apply this binary search methods, so just check that if the elements before the mid element is smaller and the element after this mid element is bigger, in that case your peak element will always come on the right. Okay, because the bigger the right element of this 21 is bigger, that means the peak element is will also come in the right side. So at that case you can skip this left part completely and then apply the binary search on this right part. Same things for the right part. For example, if your mid position is coming at this 9, so same thing you can check here also. You can check that if the element after this element is smaller and before this element is bigger. Okay, so this 11 is bigger compared to this 9, and 9 so 6 is smaller than this 9. So this type of situation is coming at the during the time of mid element checking. So you can identify that your the maximum peak element will come on the left side compared to this mid element. Okay, so here the big element is moving here. Okay, so 9 11. So in that case you can skip this part, or you can also skip this part, and you can check from here. So only this is the case. So this is the case actually. Here these two conditions are not will not be satisfied. So here we are checking in the left side, the condition is coming. So 4 is like this things. So 4 is great. So 21 like this 43. Okay, this type of condition will be satisfied on the left part of the peak element, and this type of condition. So 9, this is like 6, and this is 11. This type of condition will be satisfied on the right side of the peak element. If any of these condition is not satisfying with the mid element, at that time this the mid element will be the peak element. So for example, if you check this thing, so if your mid is coming at this point, okay, so here you can see what is the relation. 52 is bigger than 43 and greater than 51. So you can see the comparison marks here. Both are the greater than, so both are the same side, and here both are the same side, but here both are the different comparison. So only the peak element you will get this type of condition when your mid position is are coming on the peak element. So you will get this type of condition. This will not match any two these two types of condition. So in that case, you can directly return the middle element. Okay. So using these two conditions, so same process we will use. We will first check the middle element. We will just check the mid index. So for example, if you have 10 element, so we will directly check the fifth index, and so on the fifth index, we will check the sixth index element and fourth index element. Okay, and we will check these fourth index, fifth index, and sixth index are satisfying any of these two conditions or not. So if this condition is satisfied, first condition is satisfied, in that case we will skip the left part and we will apply the binary search on the right part. If the second condition is satisfied, we will skip the right part and we will apply the binary search on the left part. If both conditions are not satisfied, then in that case, we will directly return the middle element. Okay, the concept is clear. How we can check these things, how we can find this max element in this type of list using the binary search concept. If you have any doubt, you can ask the question and then we will see the solution. If anyone have another approach, you can also share. Okay, so we will use the same approach here to write the solution.
This list really does it the pattern will be available like you said, it increasing and then decreasing like that?
Yes.
Okay, that means it is easy we can
we can say that this is a sorted type of list. Okay, so if you know the pattern, then you can apply this binary search type of things.
It's not mentioned in the question itself, is right?
No, it is mentioned.
Okay.
Okay, question itself which is mentioned that. Yeah. So if you see that for some index p between 0 and n-1, the values in the array entries increasing up to position p in A and then decreases the remainder of the way until position n-1.
Okay, got it.
This type of things is given. So pattern will be given. If we will ask any this type of questions, pattern will be given. Okay. So here you have already seen we cannot solve this problem using this one line syntax of the Python. So we have to apply the binary search type of concept here. Okay. So peak unimodal. So here we are just initialize low equal to 0 and high equal to len of a minus 1. So this is the first index. This is the last index. After that, so we will apply this process repeatedly. So we are using while here. Okay, so we will not use the slicing things. Okay, we are using binary search, and we will not use the slice. Okay, so we will calculate the mid index first. So this is simply low plus high, and this is the floor division of 2. And after that, we will check these two type of condition which I have explained. Okay, so this is the first condition. If the element of the just coming before, if it is lesser than the mid position, and element just after coming to this mid element, it is greater than to this mid element. If this condition is satisfied, that means we will set our low. So that means this condition is representing the first condition which I have explained. So in that case, we will skip the low left part and we will set our low equal to mid position. Okay. So that means we have started from the here's 0 and last index. If we are getting this first condition satisfied, then we will set the low equal to mid. That means we will repeat this process on the only the right part of the mid. Okay. L, if this is the second condition which I have explained, if elements are coming in this order, if the first element is greater than the mid element and mid element is greater than the next element. So if this condition is satisfied, we will set our high to the mid. That means we will skip the right part of the mid, and then we will check the left part only. If both conditions are not satisfied, okay, these two conditions are not satisfied, then we will directly return the mid index. That means this contains the maximum value. So we will directly return this mid index. Actually, we are asking the index of the maximum element, so we will directly this mid value. Okay, so this is the solution, and we can try. So here all test cases pass because complexity is similar to the required complexity. log n complexity. Okay. Any query, any other approach, if anyone has, so you can also discuss. You can share your approach also.
Actually, when this code will terminate, because you have given while true, so when terminate.
So when the answer is here, so if actually every list will contain the always the one maximum element, no? So definitely it will return the answer. So when the return is called, our function will terminate.
At the time it will terminate, right?
Yes.
Okay.
So there is no condition to return any other things. So, but always list will always contain the max element. Okay.
Hello.
Yes.
Just the adjacent elements, when they are smaller than the mid, then the mid is the answer, right?
No. When these two conditions are not satisfied, these two first two conditions are not satisfied. So
Yes,
if you see
when that
this,
above two conditions are not satisfied, and the when the just smaller left side element and right side element of the mid is smaller than the mid, then the mid is
yes,
the answer, right?
yes. You can see the left element is smaller than the mid element, and the right element is also smaller than the mid element. So this is the only one condition when we will get our answers.
Yes.
So this condition we are not checking. So we will return the mid element in the else condition in our solution. Okay.
Here we can do low equal to mid plus 1 or high equal to mid minus 1. That will also do.
Okay, so we can try this. Mid plus 1. Yeah, it will also work because we have already checked this. Our answer is not getting.
Mid
Okay,
minus
correct. Minus 1. That this will also work. I think. Yeah, working. Yeah, yes, we can also do this. Okay, so I think this is clear to all. Now we are moving to the third problem. This is related to the graph. So in the OPP exam, one problem will be related to the graph. Okay, so you should also learn all the algorithms of the graph. So there are two big actually of the related to the graph. So definitely one problem will be there. So what is the problem? So shortest circular route. This is the headline. A traveler made a traveler plan which start from city S. Due to time limitation, he decided to choose a shortest circular route that returns to the starting city S. Okay, without using any road twice in the route. The route need not visit all cities. Okay, so these are the some constraints. So you should note down these things during solve the problem. Write a function shortest circular route W list. This is a actually adjacency list which is given W list, and one S is given that accept a weighted adjacency list W list for the connected two-way road. Connected two-way road means this is a undirected graph. Road network of n city labeled 0 from 0 to n minus 1, and another parameter S which represent the start city. Okay, so this is the first city, that means the source city. The function returns the total distance of the shortest circular route from city S. Note there is one condition is given. You are guaranteed that there is always at least one circular route. You can say that in each test case there is always a one circular. Yeah, one hint is also given. So observe that a circular route from S consists of a route from S to a neighbor U followed by a path back from U to S that does not use the route. Okay, so we will discuss this. So what you are thinking after reading this question? What algorithm we should apply? So here the adjacency list pattern is given. Okay, so that means the one adjacency list is given. Total number of nodes we can find out from the adjacency list, and one source is given S. Okay, so you have to find out the shortest circular route, and you cannot repeat any edge in this circular route. You can not repeat a vertex also. So how you can solve this problem? What algorithm which is coming in your mind first?
Hello, sir.
Sir, I think we should delete all outgoing wedges from source in the adjacent list. We should compute distract algorithm from all its neighbors.
Okay.
Then
Okay. Nice.
it should do.
Okay, nice. Others, yeah, someone is posting in the chat. Yeah, Floyd Varsal. Okay, Jivitesh Floyd Varsal. But using Floyd Varsal, you are getting the cycles information, shortest cycle things. How you will calculate this cycle? Yeah, we can also use that, but not sure about. Okay. So yes, first someone has.
Hello, sir.
Yes.
Sir, can we use DFS?
Sorry, Sanjeev, your voice is very low. No, I'm not getting properly. Can you speak loudly or some little bit?
Can we use DFS?
BFS.
No, sir, DFS.
DFS. Okay, but here we are talking about the shortest path using this weightage. So some distance or weightage is given on the edge. So how you can find the shortest path using the DFS? Okay. If there is no weightage is given on any edge, okay, at the time we can find the shortest things according to the number of edge. At the time we can apply. Okay. So here the value is given on the each edge, and we are talking about the shortest distance on the circular route. Okay, so I'm taking this graph from this problem, and then we will discuss the solution. Graph is not coming. Just wait.
Right click on the image.
Okay, I'm taking.
Can we try copy image?
Okay, I'll go. Yeah, this one. Okay, so yeah, someone is explained the approach how we can solve this problem. So for the shortest path thing, so here we are talking the shortest circular path. Okay, for example, this is a source. The first node is source, or we can take any others. So for example, we can take 0. This is a source. Okay, and we want to find out the shortest path from node 0. So and we cannot repeat the vertex in the path, and we cannot also repeat the edge. So how we can find out this? So for example, if we are moving from this source node 0, so our shortest path will always use the adjacent edge. Okay, so for example, if we are going to this, if we are starting using this edge, okay, so shortest circular path should be come from the another edge onto this vertex. We cannot use the same vertex to return on this 0. Okay, so going outside from the source, we will use one adjacent edge, and to return back, we will use the different adjacent edge. Okay, so for example, after so returning on this path, we will use different adjacent edge. So that is called the circular path. Okay, so now the shortest term is used. So we can think about the total distance of the route should be minimum, and there is no condition to visit all the vertices. Okay, you can visit minimum number of vertices if you are getting the shortest distance. So how we can apply the algorithm? So shortest things, so we can apply the digester algorithm here, but we have to apply the digester algorithm cleverly. So in that case, so first thing, what we will do, we will check that how many adjacent we have. Okay, so for example 0, so we have 2 adjacent. Okay, there is 1 2 and this is 5. Okay, after that we have complete another graph part. Okay, so after this we have this graph. So graph is connected can be connected in any way. So what we will do, so we will apply our digester algorithm. So for example, what we will do, we have adjacency list of this graph, complete graph. We will remove the one adjacent edge. Okay, we will use union find data structure for digester algorithm. Union find data structure. Okay, so I'm not getting what approach coming in your mind using this union find data structure. Okay, I'm explaining our approach, then you can also share your approach with this. Okay, so what we will do, so we will apply, so we will remove one edge from our graph. So for example, we will remove this edge from our graph. Okay, now we will check that for example, I'm not talking about this particular graph. So for example, we have another edge 3. Okay, so there are another possibility also to come to return back on the source node. So this is a source node 0. Okay, so we will remove one adjacent edge from the graph, and after that we will apply the digester algorithm on this node. Okay, so our for example, if our 0 vertex is connected this 5th vertex. Okay, so for example, this is 5th vertex. So we will remove this edge from our graph. That means in adjacency list we will remove both information. So in adjacency list, if our graph is undirected, that means 0 will also contain this 5 information, and 5 is also contained with this 0 information. Okay, then that means edge will be stored by 2 entries in our adjacency list. So we will remove these information from our graph, and then we will apply the digester algorithm on that node, this node. Okay, now digester algorithm we will apply on this node. That means the digester is considering that this is a source node, and after that digester algorithm will return the shortest distance of each node of the graph. Okay, so we can directly find out the distance of 0 node. We are applying the digester algorithm on this node, okay, and then we will get what is the distance of this 0 node. What is the shortest distance of this 0 node? Okay, we have already removed this edge, so definitely we will get another path to reach this source node. So we will note down these things. So for example, if we are getting some path from this 5th vertex to 0 vertex, and we are getting, for example, so S to, so sorry, 5 to 0, we are getting the shortest distance is 70. Okay, for example, this weight is given like 3 5 10. Okay, we have removed this edge, but we will note down this distance, because we are finding out the shortest circular path distance. Okay, so we have so the digestion algorithm will return the distance, shortest distance from S to 0. So for example, we are getting this 70 from S to 0. Then we will add this removed S distance plus 10. Okay, that means we have find out one circular path distance. So S 0 to 0, we can say that 0 to 0, we have find out one possible path. Same things. Now we will consider this edge. Now we will remove second. We will remove second edge, adjacent edge, and after that we will apply the digestion algorithm on this node. So same things. The digestion algorithm will return the shortest path from 3 to 0. Okay, so we have removed this path. So our path will come from the another way, maybe by 2 or by 5. So for example, if we are getting this 3 to 0 by digestion algorithm, for example 50, and we will add this 5 later. So that means this there is one another circular path is we are getting here, which the distance is 55. Okay, we will note down all these distance. Now the third is we will remove this one. Okay, after removing this, we will apply the shortest digestion algorithm on that two vertex, and we will return this distance 2 to 0. For example, if we are getting 90, and we will add this 3 also. So total is 93. So after, so these are the three possibility where we can get the circular path. Okay. So on the all these three so distance. So for we first we are getting 80, and second we are getting 55, and third is 95. We will return the minimum value. We directly return the minimum value of all these possibilities. So 55 will be the answer, like this. Okay. So this is the one way to solve this shortest circular path. If anyone have another idea.
And if there are negative edges, then we should use Bellman-Ford.
Yes. So if edge is negative, you can use Bellman-Ford. Yeah. But here the scenario is given in the distance way, so distance cannot be negative. Okay.
No, I mean weights are there, so weight can be negative.
Yeah, weight can be negative, but here some scenario is given actually problem. So in some problem, one story or we can say one scenario will be given, so it can be big, but the solution will be directly related to your contents. Okay, so don't afraid from this problem statement.
Why? Because we cannot be sure about the private test cases.
Yeah, private test case. So here this time actually we are using 4 public test case and 5 private test cases, and all the corner case we have also included in the public test case. If you are public, maybe some private test, some corner case will be include only the private test case. Other most of all the cover in the public also. So if your public test case is passing, so most of the private test will also pass. Okay, same for the complexity based person. So we have included the long test case in public also.
Sir, can you please explain the overview of this algorithm?
This is a simple digestion algorithm.
Okay.
Okay, so I'll explain here. And the solution digestion algorithm is given.
Yeah.
Okay, so if I think you can see that here one digestion algorithm is directly given, you can use it. After that, we will use this approach which I have explained. Okay, we will simply remove the edge, each adjacent edge, and we will apply the digestion algorithm on the removed edge vertex.
So we will remove the edge of the neighbors of the source vertex.
Yes. So for example, if we are removing this edge, so we will remove this information from our adjacency list. So don't change the original list. You can make copy of the adjacency list, and you can use the copy list. Okay. don't remove from the original list, then you will lost. Okay, so if you are removing this edge, that means that both information from the adjacency list should be removed, because this is a undirected graph. So there are two entries from each edge, so 0 to 5 and 5 to 0. So both entries should be removed from the adjacency list. After that, you will apply this diastyle algorithm on this vertex, and you can find out the shortest distance from S to 0. And after that, you can add the distance of the removed edge. Then this total distance will be, we can consider as a circular root distance. So we will save all these circular root distance in our list, or we can save anywhere. After that, after all the consideration, we will return the minimum of all these circular distance. Okay, so this part you have to written in the solution code. A diastyle algorithm is given. You can use this. Sanjeev, yes, so diastyle algorithm is given here in the mock problems. So I cannot say the same will be given in the final OPP. So if any code is actually big, so we are just trying to give some part to save your time. Okay. So if problem is directly related to any particular algorithm, like Prem says Koraskal diasta, well, when directly related to any algorithm, so you have to write the code for diasta or these things also. Okay. So here some another work is also given. So because of that, we have given this diasta algorithm. So after that, so how we can convert this logic into the code. Okay, so this is the small simple part. So here we have created one path weight list. Okay, we will store all the circular path distance here, or possible circular path distance here. And this is the one adjacency list. We will store all the adjacent information in this list. Okay, and after that, we will start our code. So first step is for node in W list S. So here small s is basically representing the source vertex or start city according to the problem. Okay, so we will find out the all vertices, all adjacency vertices. Okay, so this will return the tuples actually. Okay, so W list contains the list of tuples where the first value is represent the vertices and second value is represent the distance. Okay, so this will return the tuples of each adjacent, and we will store this tuples information, adjacent tuple information in our adjacency list. Okay, so all adjacent node with distance will come in this list, ADJ list, and after that we will perform this remove part. Okay, so remove and calling this style work. So for each adjacent in ADJ, okay, so for each adjacent we will just copy the W list. Okay, so here we are copying the adjacency list because we don't want to change the things in the original list. So we are copying here. After that we will remove the edge. Okay, so we will for removing we are performing these two steps for remove the both two entries. Okay, so you can also perform these things, and we will apply this diasta algorithm on the vertices which edge we have removed, and it will return the all distance from this vertices. So using this all distances, we will use the distance each. So this is the distance. So okay, so this is the distance. DS distance is representing the distance from the vertices from the source vertices to the source vertices, and we are adding the removed edge distance also in that. and this total distance we are storing in our path wait list. Okay, so we will store all the possible path, circular path distance here, and after performing this operation repeatedly for each adjacent, then finally we will return the minimum of all path distance here. Okay, so this will return the shortest circular path distance. Okay, so is it clear to all the logic and code?
Sir, what is this deep copy function?
Here we are copying the W list. You can simply use the W list dot copy. Actually, we cannot simply write WL equal to W list. Okay, if you will change the W list things, so internal things will also be changed. So if you remember in the Python, if you have already done Python, so I think this type of things we have covered in the Python course. So you cannot use directly this type of things during the copy. So for example, we have one dictionary D and we have one dictionary D1. Okay, so not D1. So for example, this contains some information 1, 1 like this, and we want to copy this dictionary. So for example, if we are simply writing the D1 equal to D, so both will be represent to the same object. Okay, so if D is represent to the one object that contains the dictionary information, if we are copying this dictionary like this, so D1 will also point to the same object. If you will change in the D1, then that will also reflect into the D. Okay, so these things you cannot copy in that way. So you can simply like this D1 equal to D dot copy. So these and the deep copy things.
So your argument W list is dictionary.
Yeah, where is
In the definition, this shortest circular route W list is given as a dictionary. That is why we are doing W
yes.
list.
Yeah, so here copy dot deep copy is a way to copy. So that will create a separate object.
Yeah, so this is a dictionary. That is why in the line 23 we are accessing it to enumerate the list of
Adjacent
outgoing nodes from the source.
from the source. Yeah.
So this W list S will only be giving the adjacent nodes of the source vertex, and then we are proceeding further.
Yes. So here we are actually using this W because here we are removing every time one edge of the adjacent. So we are using this WL in the digest algorithm also. Okay, after removing the edge, we are giving this WL list to the digester, so that the digest algorithm will not consider the removed edge in the graph. Okay, so this W list is the original list. After that, we are using this WL after copying. Okay, any query, any other approach? So yeah, Jivitesh is explaining some union find structure in the digest algorithm.
I thought we would use union find data structure in Dijkstra algorithm, but the code for the Dijkstra was given already.
Yeah.
So I will check that.
Okay. Yeah, another approach may be possible. So any problem can be solved by the different algorithms or different approach. So if any other approach is coming in your mind, you can also try. Okay, so is it clear to all? Any query in the problem 3? Okay. So now we are moving to the problem number 4. Yeah, so this is also a problem. So in Domino solitaire, you have a grid with 2 rows and many columns. Okay, so here one grid is given that contains a 2 rows and many columns. Okay, so and column number can be anything, but the row will be 2. Each square in the grid contain an integer. You are given a supply of rectangular 2 by 1 tiles, each of which exactly cover 2 adjacent square of the grid. Uh, you have to place tiles to cover all the square in the grid such that each tile cover 2 square and no pair of tiles overlap. The score for a tiles is the difference between the bigger and the smaller number that are covered by the tiles. The aim of the game is to maximize the sum of the score of all the tiles. Here one example is given. Okay, so here one grid is given. Here you can see. Okay, I'm explaining with the example on the notepad. Okay, so okay, so here one grid is given like this. So grid actually in the problem statement, grid is given in the 2 list basically. Okay, so this is basically 2 list, separate list, or we are using as a grid. So 8, 6, 2, 3, 9, 7, 1, 2. Okay, so so this is the form of grid. So column can be a column we can take any number of times. So here the column is 4 and rows is 2. Row will always be 2. So we will always select the 2 adjacent node, either in row and either in columns. Okay, so we can make a tile. And after making a tile, for example, if for these 4 elements we can make tile like this, so we can cover these 2, we can cover in that way. Okay, and like this. So in every tile we will calculate these things. So we will calculate the difference. This problem. So the so this calculation is given like this. So in every tile we will select the maximum element and the minimum element, and we will reduce the minimum element from the maximum element, and all these the difference we will add of the each tile, and we should get the maximum value of this maximum score we will get of the all possibility. So for example, if we are taking tiles like this, so for this tile, what will be the difference from the maximum to the to the minimum? So 9 minus 8 is 1. Okay, so from the second tile, this is the 6 minus 2 is 4. 4 plus 7 minus 1 is 6 plus 3 minus 2 is 1. Okay, what we are getting, so 5 and 6 and this is 12. Okay, the other possibility we can also take, for example, we can select like this tile. We can make in many way. So 8, 6, 2, 3, 9, 7, 1, 2. So we can make tile like this. Okay, so this is one another possibility. So here we are getting this 8 minus 6 is 2 plus 9 minus 7 is 2 plus 2 minus 3 minus 2 is 1 and 2 minus 1 is 1. So here we are getting 2 plus 2 plus 1 plus 1, so 4 and 6. Here we are getting this 6. Okay, so in all possibility of taking this tile, so our this score should be maximum. How we can select the tiles in our grade, so we will get the maximum score. Okay, so this sum of each tile should be the maximum. So this is the question. So how you can put these tiles in our grade, and so you will get the maximum score. So how you can solve this problem? What logic or what approach is coming in your mind? Because here the possibility are many, so there is no sequential way we can use here. So we have to think about with the different approach. Okay, so what's logic in is coming in your mind? Can we say the solution of this or logic of this? How we can solve this problem?
Sir, the dynamic algorithm.
Yes, so dynamic algorithm we can use. Yes, Trina.
Sir, I thought like selecting four consecutive blocks, for example, 8, 6, 9, 7, and computing the maximum sum, and doing it for every four blocks. But the solution
But
doesn't.
we can make tiles using two adjacent node only.
Yes, sir. That was the problem.
Okay, so that condition is given. We can make the tile by 2 into 1 size. So if you are selecting the combination of 4, that means either you are taking tiles are row wise, or maybe you are taking the column wise. In any two way you can take on. So this type of 8, 9, 6, 7, 2, 1, 3, 2. So if you are saying that we can select this combination and then we can select this combination. Okay.
Yes.
Okay, but in this combination you have to take the different combination also. So for you can take like this type and this type. Okay, or you can take also in that way.
We can go for
These are
patterns.
the
We can do the we can write a function mentioning that for making a different pattern. So from that we can get maximum for like that. Like you are saying.
Yeah. Yes. So, but what will be the approach to select to make these tiles in any sequential way, or what approach you want to use? Because
so here two lists are given which are all of equal length and even number of elements.
Yes, even I cannot say. Even this condition is not given, so we can take odd also.
Okay, so we can consider two lists, and either first iteration we can select the adjacent values in the individual lists, and then
So okay, so adjacent value in individual list.
Individual lists. I mean upper list and lower list.
Okay.
So like horizontal tile.
Okay, so you are saying that for example, this list is 8, 6, 2, 3, and 9, 7, 1, 2. Okay, so you are taking this 8, 6 combination. Wimless?
Then
okay, so there is one possible 8, 6.
And with
after
8,
that
6, 8, 6, then 2, 3.
Okay, 2, 3. Okay.
Then 9, 7, and 1, 2. So this will cover all the elements, and keeping the difference, sum of difference
Okay.
in one another list.
Yeah, this is
Then
the one
again,
possibility. Yeah.
then again using the same two list and using the uh, same indices of both the lists,
Okay,
then
like
it
in
will
that
take
way.
8, 9, 6, 7, 2, 1, 3, 2,
Mm-hmm.
and then finding the sum of differences and keeping
Okay.
storing it.
Okay. A1, A2.
and
Okay.
this is like two nested for loops in which we can keep horizontal and uh, I mean with some consideration horizontal. If suppose I am choosing 8, 9, I can also go for 6, 2, 7, 1 and then 3, 2. I mean those sort of combinations will have to check.
Okay. So there are lots of possibility here. Okay, so if you are selecting 8, 9, then you can select 6, 2, 7, 1, like in that way. You can select 6, 7 and 2, 1 also. Okay,
Yes,
and you can select 2, 3 and 1, 2 and then 2,
1,
1
2.
or you 2, 3, 2. So
Yes, so
there are
this
lots of combination actually.
correct.
Okay, so you can try your own approach. So maybe it will work. So you have to actually you have to find all the possible combination. If your approach is giving the all possible combination result, then you can get the result. If your approach is missing any of the approach, then maybe the answer may be incorrect. Okay, so this type of things uh, you can solve in the naive using the naive approach also. Otherwise, this type of problem can be solved using the dynamic programming approach. Okay, in that way you can divide this problem into a sub problem, and then you can find the solution, and you can use the solution of the sub problem to get the final solution. So how we will get the solution using the dynamic programming? So for example, we have this list. Eight, 6, 2, 3, 9, 7, 1, 2. Okay, so this is a list. We will create a one another list and of the size of one more than this. So here the column size is so there are 4 elements. We will take the 5 index here. Okay, we will initialize by 0 everything. After that, we will start the process. So we will start from the last. We can also start from the first. So here we are taking start from the last things. So we will just take this subproblem. Okay. So first we will just take this. So this is representing like 0, 1, 2, 3, 4. Okay. So here this is 0, 1, 2, 3. There is no 4. So we will not fill this index. We will start filling this from this position. What we are getting. So for the first for this value, okay. So what are the possibility of selection of tiles? For example, if you have tiles on which contains only these two values, 3, 2. So you can make only one tile. Okay, so there is no another possibility here. So in that case, you can directly find out the solution using this approach. What is the maximum of both the list? So what is the max? Also, for example, this is A and this is B. What is the max of A3, comma B3? This is the max, and minus max. Sorry, min of A3, comma B3. Okay, so this is the approach we can use. What is the maximum value of these two elements, and what is the minimum value of these two elements? We will subtract from the maximum from the to the minimum. So 3 minus 2. So 3 minus 2 is 1. We are getting. So if our problem is only this or contain only one elements, or we can say that contain only one columns. So in that case, we can directly apply this formula. Okay, so we will directly store the solution. So we are getting here 3 minus 2 1. So we will directly store this solution here 1. Okay, so we are solving the problem from the so actually we are just starting from the sub problems, and we will get the solution of the final problem. So this is the first step. That means if we have no element in our list, so that means the answer is 0. If we have only one columns in our list, that means if all list, both list contains only one element, so there is one possibility we can take one tile only. So of this tile, the answer is this, max or minus min of both. So we will fill this. After that, we will apply the this dynamic things. So we will use the solution of the previous solution. So for example, in the next step, we will increase the size. Eight, 9, 6, 7, 2, 1, 3, 2. Now we will increase the size. We are coming here. Okay, just see this right part. Ignore the left part. Okay, 1, 2, 3. Now we have solved this part completely. Okay, so now we have solved this value 1 here. Now if we are taking these two columns, so what are the possibility of here? So we can make these two tiles. Okay, if we are making these two tiles, so that means our solution will be 3 minus 2 plus 2 minus 1. Okay, there is one possibility here I am taking. So this is the one possibility. If we are taking these two tiles, so there is no combination. Okay, so there is no remaining part of here. So there is no remaining part is now after the selection of these two tiles. So that means this is the solution, and we will add the previous solution. So for example, from the our answer list, so we have created in before that. So here, this is the things. So here we have write the solution for if the list is empty, and if list contain the one column. Okay, we will use the solution from here. Okay, so if we are using this horizontal slide, okay, if we are making this horizontal tiles, and then we will select, we can make these two tiles, and for example, if any time if list contain more elements, so we will directly take the solution from the our solution list. Okay, so in this case, so for example, here we are getting the solution for this this step. Okay, so we can make tiles using this 2 and 3 index. So in any case, if we have, so in the next case we will discuss. Okay, so here we are just creating a logic. So we will add the next slash. So for example, we will take the solution from the, so the index is 2. For example, we are selecting the A, B. We are just at step 2. Okay, so if we are step 2, so we will just add the solution. So for example, our solution list name is RES. So this list is RES. So we will just take the RES. RES. So we are just step index 2. Okay, so we can make the tiles using 2 and 3 index. And what else which are coming apart from this 2 and 3? So we will directly read the solution in our from our resultant list RES from 4. Okay, so there is, these are the one possible combination we can take. Apart from that, we can make this vertical things. Okay, if we are at this 2 index, so we have already solved this part. Okay, in the previous step we have already solved this part, and in this step we can make the tile here, and we can directly read the solution of the sub problem. So till now we have already solved. So we will directly read the solution from our resultant list. So there is another combination is, so we will directly read this 2 minus 1, and we will directly read the solution RES of 3. Okay, so these are two possibility. We can take vertically tiles. We can make the horizontal tiles. So in that case, we will get these two tiles, and we will read the remaining solution of the sub problem. And another things, we can make vertical tiles, and we will add the solution of the sub problems which we have already calculated. And in these two possible combination, what is the maximum value? What will be the, so for example, from this case we are getting R1 and we are getting R2. Okay, so we will select the max things, because we are our main goal is to find the maximum score. So all these two possibility, we will select the max of R1 comma R2.
So how we are applying this logic of adding result 3 or result 4?
Sorry, 3.
We are applying this logic when we are selecting horizontal tiles, then we are adding RES4, and when we are doing this vertical tiles, we are doing RES3. So how we are coming to that logic?
So actually the dynamic things, we have to find out the solution of the sub problems, and we don't want to solve again this part. Okay, so actually here we are just we are starting from the one index, one tiles. Okay, so in the last things, we always start from the sub problems, and we solve the sub problems, and we store the result of the sub problems, and we use the sub problems result to solve the remaining problems directly. And we not use the, we don't use the don't solve the,
so when in the first iteration, when we are using only the last column of A, the lists A and B in the last elements, then in that case there is no need for adding RES4.
Yeah, this is the actually single step. This is the single step. We can retain this step individual. So this is the single step actually. So for example, we can write separately, because there is only one condition at that time. So I'm written again. One second, where is the mouse? Cursor is not coming. 1 second. Okay. So I'm again repeating. So 8, 9, 6, 7, 2, 1, and what is the next? 3, 2. Okay, so so this is the index 0, 1, 2, 3. So this is the whole problem. And so for example, if there is no element in the list, so we can directly return answer 0. This is correct. So in the RES list, for example, I am creating one RES list. So we are storing the result of sub problem in this list. So but here we are taking one more possibility. So 0. So this is 1, 2, 3, 4, 5, 6. So so this is 0, 1, 2, 3, 4. Okay. So actually we are taking one more size. Here we are just assuming that if our tiles contains a 0 element, 0 columns. Okay, so in that case the answer will be 0. Initially
both the lists are 0, then answer will be 0.
0. Okay, so initially we are initialized by all by 0 in the list. We can initialize simply, but we will not fill this one. We can we will directly fill from this here. Okay, so this filling is representing when we are taking only these sub problem, this only one columns as a problem. Okay, so in that case, so this there is only one possibility of the tiles. in that case, there is only one possibility of the tiles. So no need to check these things, because here the possibility is the more than, okay, here the possibility is more than one. So we have to use this logic, but in the first case, we can directly retain the solution using only one tile. So if we are taking one column, for example, if we are taking one element in each list, so only one tile is possible. Correct?
Yes, I mean, we are using kind of a slider, and from the extreme right, we are coming towards
Yes,
the
yes.
extreme left.
Yeah. So here we are just taking the subproblem with a single element. So in that case, we can directly find out the solution using this one tile, because this is the first calculation, and we can directly retain the solution like this: 3 minus 2. Okay, 1. And we can directly fill the solution for this problem is here 1. Okay, that means this subproblem we have already calculated. This part we have already calculated. We will not calculate this part again to solve our problems. After this, in the next step, we are increasing the we are just moving to the right left side, and we will just consider that if, for example, if we have 2 columns, we are increasing the size of our problems. Okay, so this is the 8, 9, 6, 7, 2, 1, 3, 2. This part we have already solved. Okay, before that, now what we are increasing the size of our sub problem. So now the size of our problem is this 2 columns. That means both list contains the 2 elements. So what are the possibility? So we can make either slides tiles in that way. Okay, and the other way is this one and this one. Okay, if we are making the tiles horizontally, so that means we will calculate the sum of both difference. So 3 minus 2 plus 2 minus 2. Okay, currently I'm not writing the res part. Okay, so here there is no part actually, so you are not getting these things currently, but this is the actually this is we have to need this in the next step. Okay, here you can understand this step, so we can find out the result using in that way of for the horizontal tiles. Okay, for the vertically tiles, so this is the one possibility of tiles, and this we have already calculated. This we have already calculated. We can directly read the solution from our result list. So 2 minus 1, this is the one possibility, and we can directly read the solution from our RES3. Okay.
Yes.
Okay. So in that way, so we are there are 2 possibilities. We can put the tile in that way, and we can put the tile in that way. So what we are getting, for example, if we are here, we are getting 3 minus 2 1 and 1. This is 2. Okay, and here we are getting 2 minus 1 is 1, and plus RES3 result is 1. Okay, so 1 plus 1 is 2. So what is the maximum value of both? 2. So we will directly fill the 2 result here. That means we can take any type of combination. So this value is calculated. Now we will move to the one more. So this is 0, 1, 2, 3, and 8, 6, 2, 3, and 9, 7, 1, 2. Okay, now we have shifted till this index. Okay, so now we are so we have solved the subproblem till this 2 index from the last, and now we are coming at this stage. So for example, if we are taking horizontal, so there are possibility of taking horizontal slides, so we can take horizontal in that way. Okay, and after that, this part we have already solved. We can directly read the solution from the previous. So here the 6 minus 2 plus 7 minus 1. and we will add the solution of the previous part. So you can see that we can directly read RES of 3. Because of that, I am putting this RES things. So we can directly read the result of if we have this 3-2. So we have already solved this part. So we will directly read the solution from the result list. And the another way is vertical. So we can remove these horizontal things and we can select in the vertical view. So for example, if we are selecting this as a vertical and we have already calculated the
We
result.
can add RES2 then.
Yes. So here we will simply 7 minus 6 and we will add that RES2. Okay, we have already calculated the solution till now. And what is the max of this H comma B? Okay, so here we will get the 6 minus 2, 4 plus 7 minus 6, and the what is the result of 3 is 1. I think 1, not sure.
Yes, 11.
Yeah, 1. Okay. So here we are getting the 11, and here we are getting 7 minus 1 plus RES2. What is the RES2? 3.
Total 3.
Okay. This is 4. So what is the maximum of both? 11. Okay. So we will fill this at here. 11. Okay. Now we will solve the remaining.
RES2 is 2, so it will be 1 plus 2 equal to 3. And RES1 will be 11.
So this is 8, 9, 6, 7, 2, 1, 3, 2. So here for horizontal, now we have come at this stage and we have solved this till now. If we are selecting in that way, okay, so we will read the solution like this: 8 minus 6 plus 9 minus 7 plus RES 2. Sorry, 0, 1, 2, 3, yes, 2. Okay, and in the second way is if we are selecting vertically. This is the horizontal, this is the vertically. If we are selecting vertically, so we can make only this and we can directly read the solution RES1. So this is 9 minus 8 plus RES1. Okay, so in that way, so 2 plus 9, 2 plus RE2 is
2.
Okay, this is 6, and here 9 minus 8 is 1 plus this is 11. Okay, so this is 12. So what is the answer? Is 12. So we will fill directly here. We will reach here 12. And in last, we will return the value of this zero index.
Basically, 2 adjacent RES positions are required for iteration. I mean, yes.
Okay, return RES0 directly. So the total 12 is solution. So is using this approach, we can return the answer, but we cannot return the position of tiles. Okay, here we are getting the correct answer. So this is the approach using the dynamic algorithms. Here we are solving the sub problems and we are using the result of sub problem to solve the whole problem. Okay, is it clear?
So RES4 is required just to put in the coding part.
Yes, coding part. This is required. So you have already seen this type of algorithm in the on week 9. Okay, so edit distance, LCS. So at that time we are also taking one more index in our matrix, and we are filling this index by 0. Okay, so because of that we have to start from the initial. So we have to take another condition for the empty things. So we will fill by the 0 things. We can use this value in our code. Okay, so in the dynamic programming things, same things we can use for the coding purpose. Okay. So this is the approach to solve with the minimum code. So if I share the code here, okay, so here you can see the we are solving this problem. So L1 and L2, there are two lists. We are taking the size from the L1s because both lists contain the same size. And if n equal to 0, return 0. You can directly return the 0 answer without solving the problem if size is 0. Okay. Otherwise, we will create a list on ANS, and we are taking one more size here. Okay, using n plus 1, and we are filling 0 at each place. And here we are solving for the last column only. So this is the only single step. Here we are directly filling by in our answer list. If the only list contain only one element in each list, that means there is only one column and one tile is possible. So we are directly filling the answer for that things using this. So answer n minus 1 equal to that max minus min. After that, we will solve this using this dynamic approach. So we will solve the vertical things. So there is only one possibility, max minus min, and we will read the answer of the remaining part. And for horizontal things, there are two tiles possible. So we will create these two tiles using the index and this thing, and we will add the remaining part project answer here also. Okay, answer I plus 2. And in these two combination, we will fill this answer I by maximum of this vertical and horizontal possibility. And in finally, we will return this 0th position value of the answer list. So this is the approach using the dynamic programming. We can solve this type of problem. Otherwise, if you want to try this to solve this problem using naive approach, it will be difficult. Okay, code is clear.
One second, please. Yes, sir. Because of this answer I plus 2, we are creating one answer list of size 1 extra, so
Yes,
that
yes.
index out of bound
Yes,
behaves as a
we are preventing from index out of range error. Yeah. And this is also correct because if the list not contain any elements, so the 0 is correct. We can fill. So maybe in this week we maybe also release some more problem for the practice. Yes. Okay, on maybe Friday session.
We can, I mean, okay, this answer can be a size anything more than n, and we can always return the maximum of answer.
Yes.
That is also possible. That doesn't make sense. What I was saying, instead of range n plus 1 in the line 5, we can make
line 5. Okay.
Yes, it can be range n plus 10 also, and in line 11 we can return max answer.
Return max. From
but
here,
then this but then this for loop will not be working correct. So it should be exactly one size more than the given list sizes.
Yes. You can take any number of size here. You can take n plus 10.
This in line number 7 will not work properly then.
line number 7. No, here we are taking actually the n minus 2. This is the size of the list actually. Okay, this is the
Yes, so we are
separate list.
if I take anything more than n plus 1
That is
in
the base
line
for
number
actually.
5, no, if I take suppose n plus 2 in or n plus 10 in line number 5, so I'm creating a list of 10 more than the given list sizes. Then in the line 7, the for loop will run for as many extra iterations,
No. So this
which doesn't
loop
make
is
sense.
iterating using this n values. This n is not related to this answer.
Ah, correct. Okay, yes.
Okay, so
Yes.
that will run the. But you can make you can increase the size, but it will read the one more. So that it will read the value from the one more index. Okay, the other
Yes,
remaining index will
and
be
instead
stored.
of returning answer 0, we can return max of answer.
Max things. Yes, we can also return max. Yes, correct.
Yes.
Because our main goal is to find out the maximum score.
Yes.
Yes, we can also return max. Okay.
But this is quite a tricky thing to understand.
Yeah, but solve a 4-5 problem of the dynamic programming, so you will get the idea how we can
So
start from the sub problems.
even the week 9 graded assignment solution codes we should be discussing. That is what I feel.
Solution code of the week 9.
9 GRPs.
Oh, GRPA. Okay. Which one? All.
Yes, I mean this was the, for me it was a very tricky week.
Okay. Actually, the logic can be different of the DP problems. So solution is very small. So for getting the idea of the solution, you have to take one example, then you can get this idea what we are doing, how we are dividing the problem into sub problems. Same things we are performing here. So what is the problem is basically write a recursive function construct word and word list, which returns a list of list in which all the way word can be constructed from the elements of word list. Then an empty list if there are no possible way to construct word with word list. Reusing elements of the word list is allowed. Okay. So here this is the first word is representing the word, and this is the list.
So, I mean the string is given and the substrings are given, and
yes.
out
So
of
we
the
have to
second
make
list,
we have to select any substring, and we have to make this main strings apple if it is
yes, I
possible
mean
or not.
any combination of substrings making the word.
Okay, we can use the same substring many times also. This is also given. Okay. So here, yeah, we can also apply the DP thing. So we can just start from the small parts, and we can check that things if we are getting a combination of apple or not, like this. So we have to read the solution.
So, I mean, how should we approach this problem?
One second. If word equal to empty, return this. If not, return so word equal to word. So okay, here we are using the recursive approach, I think. So word list equal to construct word length. So this is also recursive call. So this is not actually DP. This is a memoization things. Here we are using the recursive call also. In DP we not use the recursive things. Here actually we are performing this recursive things, and in recursive things we are just checking for the all possibility by creating this recursive approach. And but we are storing this sub solution list in the memoization table. Here we are creating one memoization dictionary. So okay, we have to come up with step by step. Have you tried with the example of this code? So
I couldn't understand. I didn't go too deep in the solution code. I wanted this to be discussed in live session.
okay. So what is the example? Solution is given. So apple is given and the combination is given. So we can try with these things. Like this. So here actually the question is asking of the combination of each. So we cannot use the DP approach here. Because DP approach is used most of the time. DP approach is used to return the maximum, minimum, this type of optimization, this things for return. So we use the DP to return this optimization things, maximize or minimize these things. Here actually for returning the solution, what are the sub combination is there? So we have to apply some all possibility combination. So for example, if we are taking sub problem, so we have A, P, 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 L, E. So for example, if we are starting from the first value, so we will check the solution if it is possible. So if word is, there is no word in the list, first word and word list. So what is not in return this? Word is in memos key, return memo word. This is for the memoization, and two word is this is the empty. This is for the result. Now this is the main part of the solution. Okay, so for subword in word list, so we will read the subwords, and here we are actually calling the if subword equal to word list, the length of the subword equal to what is subword? Subword is for example AP and word. Word. So word, what is word is apple and left line of the. So what we are matching here, so word lane of subword. Okay. So lane of subword is 2. What we are checking here. Okay. So this condition is actually checking if the subword is coming in the as a prefix of the word or not. Okay, so this condition is true. Then we are performing the next things. Subword list equal to constructive word. Okay, and we are removing this first element and we are checking again. Okay. So what we are doing actually, we are just reading each sub words here, AP like this, for example. Okay, and we are checking that this AP is coming as the prefix of our word or not. If it is coming as a prefix, so for example, this AP is coming as a prefix in apple. Okay, so we are just calling this function recursively and we are removing this part. We are removing this part from our word. Okay, here you can see that we are removing this part from our word and we are just passing whole list. And in the next iteration, when we are calling this part again, So that means this part again we will check same things. Now our word is PLE. Okay, so same things we will using this for loop we will check these things. If AP is coming as a prefix, so this first letter is not coming as this as a prefix of our remaining word PLE. Okay, so we will move to the next PPLE. This is also not coming. Now we will move to the next APP. This is also not coming. APL not coming. APPL not coming. LE not coming. Now PLE. If you see that this PLE is coming as a prefix, or it is also matching a whole word. So that means we have so we in the previous part. So in the first things we have checked this AP things. Okay, after that we have recursively call of the remaining part, and we get the matching through this PLE things. So this is not a DP things. This is here we are using the different approach, using this recursion approach. Okay, so after checking the first part, so if we found the AP as a prefix of the word, then we are checking for the remaining word after removing this matching. So here we are getting PLE. So we will check the PLE things with all the word if we are getting any matches. So you have already noted that we have found the AP first things and PLE last things. So we will save this combination. So here we are saving the combination of this total word list dot extend subword plus LST for the list in subword list. List for the listing. This is no. Total word list is extend. Why we are using this total word list extend subword. Okay. Plus LST or subword list. Subword. Yeah. Okay, so actually we have removed some things. Total word list where we are using this one. Extend subword plus the LST. This is LST for LST in what is LST? Subword list. Okay, it is returning y from here. Okay. Actually, in this list, we are just storing the result from this. So this subword is coming from here, and we are using this LST for LST in subword list. So here this subword list result we are getting from this. Okay, and we are returning the solution. So we are adding the solution in the same list. So because of that, we are adding the solution in the same list using this extend things. Okay, so after that we are returning this total word list. So every time we will add this total word list by extend these things. So simple logic is that we are just checking this thing. So we are just checking this AP things by Apple word. If it is matched with the prefix, we are just remove from the prefix part. Now we will match this PLE part by all words. So same we will also check. Okay, so we are getting this PLE combination. So there is one combination AP plus PLE. Okay, this is the first example, the first test case. So if there is another test case,
Yes, it's clear now. I mean, it will iterate through the given list of words, and for each substring, it will remove from the given word.
Yeah, remove from the prefix part which have already matched, and we will check for the remaining part. Okay.
No, but suppose PPL is the second element. So how it will remove from Apple PPLE?
No, we will remove after only matching. When we have matched any prefix, so we will check that.
No, PPLE is a suffix, not a prefix in Apple.
No, actually we are checking prefix in the word. So this is a word actually, APPLE. Okay. Every time we
Yes.
are checking as a prefix things. So first time we have found
No,
AP.
for subword in word list, this word list, we are going through all the substrings, correct?
Yeah, for subword in
So,
word list. Okay, this is the things. Okay, correct.
so we are iterating through the substrings in the word list.
But
So
here actually
like AP is,
we are using this recursive call. So this will work in the different way. In this recursive call, so here we are calling the new algorithm. So here we are repeating this process again, same things in that part. Okay, when we find out this AP things, if this AP thing is matched with our word initial part, so we will remove these things. So PLE, this is the now new word, and we have start from this again. Now here our
correct.
word is PLE,
This is
and
first
rest is same.
first AP is clear. AP is clear. Now the second element is PPLE. So when it goes to the second iteration for subword in word list and it goes to PPLE, then how it will be done? If subword is equal to word dot len subword.
So okay, I'm coming to that. So for example, in that case, the first case we found one result. Okay, AP plus PLE.
Yes.
Correct. In the second case, for example, if you are checking this PPLE, okay, we will start from the Apple. So we will check that this is coming as a prefix or not. So PPLE where is coming? It is not coming as a prefix. Okay.
No, it is not coming as a prefix.
Yes, so we will skip that because here we are taking this condition. Subword equal to word colon len of subword. That means what is the len of this subword is 4. So we will take this part. We are actually matching this part of the word. This is not matched. So if this is not matched, that means we will skip this part completely. Okay. So that means for we will move to the next word. So we will come here. Okay. So now APPP is matched. Okay. Now the LE is remaining. So LE will be matched by this, by the recursive call. So in that case, we will find out APP plus LE combination.
Okay, so this is kind of implicit thing is given like in the word list, all the substrings will be in sequential manner. I mean, it cannot be like PPLE then A.
Yes.
It should always be A and then PPLE.
So what should be exact match by the combination? Actually, we are just merging this substring, and we are getting this word. So we have to match the word accordingly.
So if a single element A was also there in the word list, then A and PPLE would have been.
Yes. So if A is given, then A will be matched by first character. Then we will check for the remaining part, PPLE. Then we will check for the remaining things. It is matching or not. So actually, in that way, we are checking all combinations. So we can say that we are performing the all possible. We are checking for the all possibilities.
Yes. Sir. Yes.
Okay, but here in some way we are storing the result also, memo word. So these things we are actually using memo word and total word list. So we are using the sub. So if word is coming directly, we can check. So actually this is recursive approach, and during the return of these things we are using this memoization thing. So to understand this memo part, we have to create the recursive call that we can get memo word things.
Memo is the dictionary, initial empty dictionary created, and then word is being stored.
Where we are filling this memo. Here we are directly. What is the word? Word
is apple.
Word is apple. Okay. And total word list. Okay. what is the use of this? So we are using anywhere. Okay.
Yes,
Here
yes,
we
we
are
are using this memo.
okay from this one. Okay. So if we have found any combination already before that type of things, because of that we are returning directly. Return memo word. Okay. Solution. Okay, so during this recursive call, okay, so if we have already solved any part, so for example, for any word, for example, PLE, we have already solved before that. So we can directly return the solution from here, directly memo from word, and we will return directly. We will not check. Okay, so for example, one time we have found this PLE. For example, for word PLE, we have already checked in the first step, and we found the match here. Okay, so we will not check again this for PLE. For if we are getting the same word again. For example, the word is same in any other another word possible things. So we will not check again this part. So we directly return this thing from here. So I think is it possible in that case repetition is allowed or not? So memo, I think memo is already, we can use the memo things if the substring is repeated only. In that case, we can use the memo information. So app, apl, appl, ple. So is there any condition of substring given? Which returns the elements of the word written in empty list if there is no possible way to construct using element of the version. Yeah, so repetition of the substring is not given. If any time if the repetition is used in problems, so we can yeah, it is possible. Okay, correct. So for example, if we have two strings, if we have a list like this, ap and pl and le, okay, and there is a one also possibility or le, okay, ple and app. Okay, so in that case, for example, if we are checking this app, not app. So for example, if this app is matched with the first part of apple, okay, so now next part, next word is to check for this is ple. Okay, so not matched. Okay, so for example, if we are taking this okay, app and l, so in that case, if we are taking the match with app, the second word will be le, okay, plus l. So that means we have checked for this app word, and we have already checked this le word. In the second case, for example, when we are checking this ap part, okay, so ap, in that case, our remaining word will be ple. So
PLE.
Okay, yeah, ple. I think 1 second I missed. Correct example. Okay, these things we have to remove. Yeah, so for these things. Now see, if we are the first, we are selecting this first element, app, in our list, then what will be the second word will be l, okay, and if we are selecting the second word, so ap, and we will check the ple part, so now next word is p, we will check for the p. Now the remaining word will be le, so le word we have already calculated, So we can directly see the solution of the LE in the memo table. We have already checked for this LE, and this is available in our list. So there's no need to check by the whole list. So we can directly check the solution if LE is available in our memo table. So we can read the memo table solution from directly.
No, but how LE will be there in memo?
Because in the first part we are storing in that now. So after returning the solution, we are storing in our memo.
No, but is LE as a key available in memo?
Yes, word we are making the key. So if you see the solution, here, we are making this word as a key, and word we are coming from this part. Okay, so every time when we are calling recursively, so we are removing the first already meshed part. So for example, we have removed the APP part, then LE will become in memo. In that case, so we can directly check this information in our memo table and we can directly return this.
No, but for if suppose LE in the case we were discussing, if LE is in memo, then it will return what? Memo LE will be what?
So it is actually returning the previously calculated solution. So we have already calculated the solution in this step, total word list. So in that case, that means we have found one matched list with LE. So we are storing this LE in this total word list. So we have to, I think, debug this code. Then we can identify what we are getting in the total word.
Can we discuss the next one?
Okay. So just debug the code and print this total word list. So you will get the idea.
Sure, I'll do that.
Max coin path. So this is max coin path. Oh, this is not related to DP also. Okay. Just check. Yeah. Given a 2D matrix M where each cell contains MIG contains some number of points, find the path to collect maximum points from cell X. Condition is given. You can only travel one step right, or you can one step down. Okay. What is the maximum value? Okay, this is the DT. This is the similar to like our already discussed solution in the so actually here we are taking some condition, otherwise this is a simple DP approach. What we are doing, first we are creating a two-dimensional matrix. Okay, so this is the creation of matrix same size of M and initialized with 0. So what is the size M? What information is given? What M is representing M 2D matrix M where each cell M contains M matrix. Okay, matrix is given. Okay. So same size of matrix, we are creating another matrix. After that, we are filling using this dynamic programming things. So in that part, mcp.apply. So this thing is we are creating a one new matrix MCP. This is for the solution. So we are filling this matrix by 0 completely. Okay, and initialize x1 row and y1 column. What is this? X1 row and y1. Also, okay, this information is given. X2 and y2. Actually, in the question, we are asking the path from the mid also. No? So we are giving the 2 points, and from this, these are the source points. So for example, if we are giving this 0, 0 point, to 4 point. So we have to return the maximum coins
Maximum
path.
collectible coin.
Yeah, maximum collected coins path we have to return. So where from we are starting, we will start calculation from there. So for example, if we are starting from this 2 point, so we will start from this 2 point to calculate the to our solution. So because of that, here we are filling this initialization things. So here we are actually filling this information MCP x1 y1. So we are directly reading the value of what is the value of. So I think we have to take one example, then we can directly solve. Okay, I'm taking this same image. So for example, in that case, if we want to solve this problem, this is the 0 point, which is the first point, and this is the last point. Okay, so what will be the answer? So here x1 equal to 0, y1 equal to 0, and this is the x2 equal to 4 and y2 equal to 4. So in that case, we will start from this position. If any time if we are giving the source point from here, so we will start to solve from this position. Okay, so here we are creating one another list of the same size. We can directly retain the solution here. We are creating directly. 3, 4, 2. Okay, so the same size, and we will read the value from here too directly. Now we will fill the matrix. So for I in range of y1 plus length. So y1 is this 0 and plus 1. So we will fill from here. Okay. Okay, that we will also fill. So we will fill the first row for I range y1 plus 1. Point these things and length. From these things to till now. Okay, and we will select mx1 or y. Okay, plus. Okay, so for the first row, we will fill this matrix. Why actually we are creating all possibility to select the coin. So for example, if we are filling this on the right side, so we will just add the coins from the previous coins. So for example, if we are filling the coins value here, so what is the way to come at this point is 2 to 1. So in that way we will get the 3 coins. In that stage we will get these 3 coins here. Now for the next place, if we are coming 3 to is 3 to this place. So okay, so 3 plus 3. So till now we have get the 3 coins. Now we are selecting the path from to the right in that way. Okay, so 3 plus 3 is 6. Same things we will if we are selecting the path again. So here from 6 to 2, 2 is 8. Now 8 to 5 is 30. Okay, so this is the one possibility of the way we are moving in that way. Same things we will fill in that way also. So 2 plus 3 is 5. Now 5 plus 7 is 12. Now 12 plus 2 is 14, and 14 plus 1 is 15. So we have filled one row and one column. Okay, now we will repeatedly fill these things for I. Okay, one second. So for I range this. Okay, so the columns. Okay, now after that we will fill using in that way. So this is the part of the filling first row and first column. After that, we will fill by this logics. So for example, we want to fill this. So what is the maximum value we can get? So we can come from this side and we can come from this side also. Okay, so we will select the maximum of both paths. Okay, if we are coming from in that way right, then down. So we will get the point 3 plus 5. So this is the point value is 5. So 3 plus 5 is 8. Okay, so we are getting this thing. And if we are coming from this side, so 5 plus 5 is 10, which is the maximum 10. So we will fill this block by 10. Okay, so this is the way to fill this matrix. So same things we will repeat for the next column. If we are coming from this side, so 6 plus 2 is 6 plus 2 is 8. Okay, and if we are coming from this side, so 10 plus 2 is 12. So what is the maximum is 12. We will keep is 12. Same from here, 8 plus 4, 8 plus 4 is 12, and 12 plus 4 is 16. We are getting 16 maximum, so we will remain 16. Now 13 plus 6 is 19, and 16 plus 6 is 22. This is the maximum 22. Okay, so we will repeat the same process. Actually, for the first things, so there is only one way to move here. So we can for the first row we can move only on the right side only. So we can move on from first column to second column, then third column, then next. Okay, so because of that we are directly filling this row. Same things if we are moving in that way, so we can directly filling this first row. But after that there is more than one path are available. So we will select the maximum possible, maximum coins path. So you can see that every position we can come from the two sides, from the top and from the left. Okay, so in the both direction in which we are getting the maximum points, we will fill by the maximum things. So same things we will repeat for the whole, and in the final column we will get the maximum points. So here you can see if we repeat this process, so 12 plus, if we are coming from the top, so 10 plus 6 is 16, and 12 plus 6 is 18. So we will fill by 18 here. Okay, same for the next by this. So 12 plus 1 is 13, and 18 plus 1 is 19. So we will fill by 19. And same from the 16 plus 3. 16 plus 3 is 19, and 19 plus is 22. And now the
so basically we are maximizing each cell in the entire
yes. So we are solving. So actually we are using the same previous sub problem solution. Okay, every time we are using the previous solution, and we are finding out the next solution. In the final column we will get the answer. This is the maximum points value. Okay, this is the DP approach. Actually we are using the previous sub problem solution.
I had tried not exactly but similar approach, but only 2 cases were passing. But now I know where I could have made mistake.
Yeah, so just verify your code again, then maybe you will get all the test case pass. Okay, so this is clear. Approach is simple. The problem third is longest decreasing sequence. Okay. Yes. So longest decreasing sequence here we are finding out. And so same things. So here the sequence is given. So we will use the DP things. So we will take one example. Five. Okay, we are getting the 5. So, okay, so the one sequence is given 0 2 7 3 7 3 8 2 1 0. So what is the longest sequence is there, and what is the length of this longest sequence? Decreasing sequence basically. Okay, so decreasing sequence can be made from any place. So for example, if you see the 7 then 8, so here in this example, yeah, 7 3 2 1 0. Okay, so here we are this is the longest decreasing possible sequence. So the length of the sequence is 5. Okay, so but how we can find these things, because there is no sequential way to solve this problem. So here actually we are just taking one solution result and we are filling by this one LDS count. Okay, so LDS count we are taking and we are filling by 1 for each value of the list. So here, for example, this is the 1 1. So 1 2 3 4 5 6 7 8 9 10. So 1 2 3 4 5 6 7 8. So because every digit we can count as a 1, because we can take as a result. Like for example, if our list contain 1 1 1. Okay, so in that case, what is the longest decreasing sequence is only 1. Okay, so there is no possible decreasing, strictly decreasing we can take. So all value are equal. So because of that, we are just directly initialized by 1, because this is the minimum possibility. After that, we will apply these things, DP things. So here one list we are also creating previous value with respect to the index. Okay, we are also indexing previous none. So 10 times none we have to store. Okay. After that, for I in range, P max equal to L0. Okay, P max equal to L0. And for J in range, LJ is discount equal to P max. Okay. So let's count all those things. So pre-max things we are just taking for I in range. So I in range I equal to 0. So in that case, we are just considering that this is a pre-max element. Okay, for after that, I support J in range I. Yeah, so for initially we are just solving this sub problem. So just consider that we have only one element, 0. And in that case, what is the LDS count? Okay, so in that we will match that how many elements are coming which are greater than this element. How many elements are coming before this element which are greater than this element. So that will be considered as a decreasing sequence. Okay, so in that case there is no elements which are greater than this element and which are coming before this element. Okay, so there is no solution for this. After that, we will increase the we have already calculated the solution for this part, and we have just filled this value by 0. Okay, so we are just filling this pre-max pre-information where we are filling this value. So pre-max equal to LDS count if this condition is true, but this condition is not true in the first case. So for first case, yeah, okay. So okay, so in the first case there is no condition will be satisfied, because here LJ is greater than Li. So actually this loop will not run because the I equal to 0, and we are passing the 0 in the range of the I. So this loop will not run, and we will just store this LDS count of I value 1 plus premax. So premax is equal to 0, and we are just directly filling by this premax 1 plus premax update. Okay, so 0 plus 1 is so what is this? Premax 1 plus premax is L0 of this. So 0 plus 1 is 1. Okay, so this will remain same. After that, we will increase the size, okay, of the subproblem. So in the next case, we will consider that if we have two elements. Okay, so in that case, we will just read as a premax. Always, we will always select this premax things as the starting element 0, and we will just check that if is there any element which are greater than this two elements. Okay, in the next case, we'll check these things. So there is no element which are greater than. So this condition is not satisfied here. So there is no element which is greater than this two. So in that case, this means this loop will be passed, and we will add this 1 plus premax. So that means this is the one. Okay. So same things we will repeat from the 7 things.
No, I mean, and when we are taking two elements, then it will run 2 times. No, I mean, second time it will go into the loop.
No. Actually, we are taking range now. So if we are taking I equal to 1, so loop will run for only 0. In range, if we are passing 1, so loop will run only from 0 to 1 minus 1, 0. That means this there is only one value.
Okay. So range 0 means nothing. Range 1 means 0 only.
Yeah. So if we are taking range 5, for example, so our loop will always run for 0 to 4. Okay, so same things for the 7 things. So we will start from the checking from the 0 side from here. So this is not greater than the 7. Okay, so we will skip that part. So we will check for the next elements. 2 is not greater than the 7, so we will skip that part. Same things. That means here the value will remain same 1. Okay. Now in the next step, if you found this 3. So you can see that 0 is not greater than, 2 is not greater than, then 7 is greater than. Okay, in that case, if you are finding out this greater this value, that means we are finding one decreasing sequence. 7, 3. This is a decreasing sequence. So in that case, we will increase our count for this value. So for this solution here, that means this condition is satisfied. In that case, we will just read this premax value for LDS count of J. So we will directly read this one value from here. Okay, and we will assign this as a premax and prev of I. So prev of I. Yeah. So for in this prev things, I think we are not using this prev anywhere in the solution. Okay, I think we can remove these things. So there is no use for this list. We can remove this. Okay, so actually we want to return the maximum length of the longest decreasing sequence. Okay,
no, we want to return the maximum length list.
Oh, list is asking. Okay, then this information is required. Okay, because of that. So yeah, in that case, we will fill this prev information. So prev I. So what is the prev I is J. So J is this. Okay, J is representing this. Okay. So in that case, we will store this information. What is the index which are coming before this? So for 3, we will store this prev of I. So I is representing here, and we will store the index of this 2. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah. So in that case, we will store the previous element, but previous we are considering for selecting this. So what is the previous index is 2. So using this index, we will return the sequence. Okay, and we will increase this premax. What is the premax value is 1, and we will increase this premax by 1. So 1 plus 1 is 2. We will update this is 2. That means till now we have get the solution 2. That means the decreasing list length is 2. Okay, now we have solved this part. Now for the 7. So here we are getting 7. We will check that is there any element is greater than this. So 0, 2, 7, 3. There is no greater element. So we will keep remain same. So that is will remain the same. Now this is 3. So in that case 3. So 0, 2, 7. So there is one sequence we are finding from here. Okay, so 7, 3. This is making a decreasing sequence. So in that case, in the first step, we will fill by this index 2. Okay, and we will increase, we will read this value 1 count, and we will add by 1. So we will store 2 here. Okay, so 2 we will store. And we'll repeat the same process again. So we will check for the 3 also. 3 is not greater than, then now this 7 is greater than once again. Okay, so same things. Now we will update these things. So here the same things we are finding the greater value. So 7, the index is 4. And we will read the count value from here 1. 1 plus 1 is 2. That means so we will update this count value if we are finding out the maximum value from the previous value. Okay, so if you see that this things mx equal to max of the LDS count. Okay, so we are storing this all LDS count. Oh, no, this is a solution actually. Premix. Yeah, here we are actually we are just reading this premix, and we are updating this 1 plus premix things. LDS count. Okay, so here we are taking this condition. If LDS count of J is greater than Pmax. So because of that, this will remain the 2, because from this 7 we are getting 2, and from this 7 we are also getting 2. So this value will remain the same. If any of the value we are getting the maximum value, we will update by this maximum value. Okay, so for the this case this is 2. Now for next element this is 8. That means there is no solution for because this is bigger. And in that case, for if we are selecting this 2, so 0 is not greater, 2 is not greater, but 7 is greater. Okay, so 7, 1 plus 1, we will update by 2 in the first step. Okay, and in the next case 3 is also greater than this 2, so we will read the count from here 2, and we will add by 1. Every time we will add by 1 by the premax value. So 2 plus 1 is 3, so we will update by 3 here. Okay, in the next step we will 7 is greater than this 2. Yes, so we will read the value of 1 plus 1 is 2, so we will not update because the last maximum value is 3. And next step 3 is also greater than this 2, so we are getting this 2 plus 1 is 3. So finally we for this 2 we are getting this 3 index, and we are getting this 3 index by this last index is 5. So we will update the 5 index here. Okay, so this is the 3 value for 1. Now for 1 we will check here also. So 0 is not 1. Yeah, this 2 is bigger. So 1 plus 1 is 2. Okay, so there is one possible 2. And for 7, 1 plus 1 is 2. Okay, so we are getting another 2 value. So, okay, so we will not repeat the same. Now 2. So this things 2 plus 1 is 3. And same things 1 plus 1 is 2. 2 plus 1 is 3. Same thing here also. So 1 plus 1 is 2. And from this 2, 3 plus 1 is 4. So finally we are getting this maximum. So this will be updated here. Okay, so and we will read the index, this 7 index here. Okay, so now this is the counting value. Same for the 9th element. This is 0. So same process we will repeat from the starting, but we will get the maximum value from this. Okay, so this 1 is greater than this 0. We will directly add this 4 plus 1 is 5 here. and we will store the index here. So this is 8. Okay, so if we are asking that what is the maximum length of the maximum decreasing sequences, this is, we can directly return this 5 value. This is returning a maximum length of, sorry, length of the maximum decreasing sequence, longest decreasing sequence. So we can directly return this value. But for returning a solution, one possible solution for returning it, so we can repeat this process from here. So here we are getting the solution 5. Okay. So okay, so yeah, we will not return the direct last value, we will return the maximum of the value. So for example, in this list, LDS count list, what is the maximum value we are getting, we will return as a solution the longest distance length. But for the solution, we will check that where we are getting this largest value. So for example, we are getting this largest value here, that is at last index. So this is the 9th index. So we will read the previous index from here. This is 8. Okay, we will move to the 8. We will read the previous index from here. So this is 7. And we will move to the 7. Then we will move to the 5. Okay, so the 5 is here. Now we will move the this is 2, I think. This is 2 or 4? Yeah, 4. No, this is 2. No, this is 4. Yeah, this is 4. Yeah, this is 4. Okay, so 4, there is nothing. And so this is the sequence. We can directly read the element from this index in this sequence. So 4th element is 7, and 5th element is 3, and the 7th element is this 2 and 1 and 0. This is a one possible solution. Okay.
Thank you, sir.
Okay. Okay, any other query?
I tried a very weird solution. It didn't pass all the test cases. It passed only 2 test cases, but the solution I found that to be a really weird solution. I tried.
I think you are trying the naive approach.
It was totally weird solution.
So no issue actually, that this type of actually DP is not easy things. So it's totally depend on your practice. So how much problems you have already solved in the DP concept, then you can come up with the logic. Otherwise, every problem have contains the different type of logic in the DP solution. So
Actually,
after
I tried the writing the code. I tried seeing the output on Repellate, and basis that output, I kept modifying my code, which was totally, I mean, not in line with the solution we discussed right now. But somehow I could pass out the given test cases, but not private test cases.
Okay. So yeah, so same things now. Sometimes, for example, of the coin problems. So that problems I have already discussed. I think you were in the session. Coins problems I have discussed. So that problem looks like, say, greedy problems. So for example, if we have a coins 10, 5, 2, okay, and we can select any number of times these coins, and for example, we want to make this 55. So what is the minimum number of coins is required if we are selecting? So we can select 5 coins from the 10, and we can select 1 coin from the this. So total 6 coins is required. But this type of problem, so this is looking a greedy approach. We can simply sort the coins value, and we can start selecting from the largest value coins, and we can so if, for example, if this 10, we just divide this 55 by 10. What is the remainder? Sorry, remainder thing. What is the remainder 5? Then we will check the next smaller value. This is the one. So here we are getting 5, and here we are getting 1. So we can return the solution like this. So this type of problem, in the first looking, it looks like a greedy approach, but sometime it become fails. So that type of problem also can be solved using this DP approach. So for example, if we have a solve 9, 6, 5, and 2. Okay, not 2, 1. And if we are giving the value 11. So in that case, if you see that, so for example, if you are applying this greedy approach, so you will always select this one coin of 9. So after selecting of this 9, you have to select 2 coins of 1. Okay, so the total coin will become 3. But the solution is 6 plus 5, 11, using 2 coins. So in that case, this greedy approach is failed in that case. So this type of corner case, sometimes the problems looks easy and you apply, most of the time student applied the naive approach or some greedy approach to solve this problem. So some test case are passed, maybe okay, so but not the corner case. All the corner case pass. So this problem can be solved using the DP approach. So same things. If you're trying some another approach, so maybe some test case become pass, but not all. Okay, so just try to solve some different types of 10, 15 problems based on the DP. So after that, anytime you can find the idea, so how we can divide this problem into sub problems and how we can reach to the main problem solution. So DP is not a very easy thing. Okay. Okay. Another query, Bhavya, Abhijit. Emlis. Okay.
I hope we don't need to memorize the codes for different graph algorithms.
Not
I mean,
memorized.
if application is asked, then that will be logical. If we need to write the code
No, so
from
for
scratch,
example,
then
if any problem is solving by the Prim's algorithms, so you have to remember this Prim's algorithm concept. I'm not saying that just remember the code, exact code, but you can write the code for the Prim's algorithm using the concept of Prim's algorithm, because these are not the fixed algorithm, but there is one idea for every algorithm. There is some concept is behind of the every algorithm, so you can use the concept and just write your own code. That is also a problem, no? So Prim's algorithm is also one problem, but someone is have assigned a name of this problem. That is called the Prim's algorithm. If you know the Prim's algorithm concept, why you can't write the code for that? But we will not give the big code like the AVL tree codes, all pair shortest path codes that are very weak, so that cannot be remembered, and that is very specific. But graphs algorithms are very important, and that can be used to solve any problem. So you should remember the concept, not the code, and using the concept you can write the solution code. Okay.
Okay, sir. Thank you, sir.
Okay. Okay. If we any, so Bhavya, Vijit, if you have any query, I don't know you are like. Okay, so bye everyone. Maybe in this week we will also release some more problems, so you can practice on that. Thank you everyone.
Thank you, sir. Good night.
Good night.